Hi, John. Thank you for being here.
Serena, thanks so much. It's a pleasure.
So we're
So,
having John today from SuperRare, and I'm Serena, CEO at MoCDA. So John, can you tell us a bit about SuperRare?
sure thing. As Serena mentioned, I'm John, the CEO of SuperRare, and SuperRare is a platform designed to enable digital artists and collectors to build community. So it's a community of artists around the globe, collectors around the globe, coming together and appreciating art. And I'd also like to just give a shout out to CADF. Thank you so much for involving us. Really appreciate all the hard work you guys are doing to kind of bring greater awareness to this ecosystem that's evolving around digital art.
Absolutely. Thank you so much, Graf, for having us and inviting to share this workshop that we're actually going to be having in a few moments. So the reason why John and I are here today is because we are discussing SuperRare as a gallery model and how successful this has proved in the last few years. So I just wanted to ask John, why do you think SuperRare has become one of the most successful crypto art project, and why do you think your vision as somehow proved to be one of the best gallery and most welcoming place for artists?
Sure, absolutely. Yeah, I think there's really two components that are part of it. One is really partnering with the artists. So we have a pretty long onboarding process where we kind of talk about how the platform works. We do short interviews with the artists to get to know them. To really, there's a lot of education involved. I think people get excited when they hear about, what's happening. And we put a lot of emphasis on like bringing them in, kind of showing them like, okay, here's how everything works. Here's a good way to kind of think about, how SuperRare is structured. And then the second component there is, a big emphasis on the community and collaboration. So I think one of the things that's really exciting about digital art and digital art collecting is it's happening in real time and you're actually making connections with these artists and collectors, so you're getting to know these people. We're all hanging out, having live streams like this, chatting. And so, it's more than, it's not just a transactional model, right? It's kind of like, it's a community of friends hanging out together. And I think that's really, the part that's pretty powerful.
Absolutely. And I can totally say that the community has proved to be one of the most successful elements in this project. And is there something that you would like to share with us in terms of the vision that you guys are looking to bring forward?
Yeah,
Instead of
absolutely.
developing SuperRare?
Sure. So, we launched SuperRare 2 years ago. We kind of, tried to build the simplest, product that would be useful to both collectors and artists. And I think, it's proved to be that. And, just thinking forward, what does this look like when, there's millions of collectors instead of thousands of collectors? So one thing we've done there is launching the editorial recently. So that's been super great, kind of like just building upon the existing community and kind of, trying to raise more awareness. And then, also really, just kind of like trying to dig into the great, there's a huge ecosystem that's evolved basically. And so thinking about, when we launched, there wasn't a good place to tokenize. Like this is one of the first things you could do. And so now thinking forward, like what are things that both collectors and artists need? Now that the ecosystem is here, there's a bunch of different options. And so what does the next iteration of this look like? So this is looking into things like, streaming art on different devices and just trying to, kind of keep with our original ethos of like building tools that people found really useful. So just trying to identify those opportunities and keep growing the community.
We're very excited to see what SuperRare is going to bring to the audience next. But for now, we're going to be diving into the behind the tech of the SuperRare Art Gallery. So stay tuned with us as we launch our first of a series of workshops within MoCDA in collaboration with partners. And today here with SuperRare, we're going to be looking at the smart contracts and the tech that is used to run the SuperRare art gallery. So we hope you enjoy this workshop. And once again, thank you, Kraf, for having us. Enjoy the workshop, and any feedback, if you'd like to reach out to us, stay tuned in. We'll share emails and social contacts to reach out. Please share your feedback and enjoy the workshop. Thank you. And thank you so much, John, for this collaboration. We'll speak to you very soon. Thank you, John.
Absolutely, Serena. Thank you. Take care.
Hey there, everyone. Thank you for staying tuned in. I'm now here joined by Dominic Perini, CTO at MoCDA. Hey, Dom.
Hi, Serena. Thank you for joining this workshop. I think there's a lot of material to cover, so let's dive straight into it.
Let's do it. Sounds very exciting. So if you want to guide me so we can get through some questions together.
Okay, that's cool. Here we are on Firefox, but any other browser is cool. We are already on the address, which will be communicated separately, where this sources for the workshop is located. So we can take a look at the content of the README. If you want to read a bit of an introduction about smart contract, there is this article that has been published recently. Otherwise, let's go straight into it by taking a look at this diagram. So what we can see on this diagram is an overview of the smart contracts that is derived from the use case at SuperRare. So SuperRare has got a variety of smart contracts in order to perform operations on the back end of their gallery. And what I did in preparation for this workshop is to simplify all this in order to make it presentable in this context of our workshop and get people to understand it better. So essentially what we can see on the right side of the screen, we are using a dependency library which is called OpenZeppelin. OpenZeppelin provides us several implementations of a variety of ERC standards. So the ERC 721 refers to the non-fungible token, and we can see here a list of operations that we invoke from our smart contract. So we take advantage of an already built library, and this library has got some data inside, data related to ownership, data related to control, and data that links our tokens to an external URI. In addition, there are some very simple data, such as the name of the smart contract, the symbol that is used, and a base URI. A URI, again, is a location, like an URL, like this one above here.
Okay.
Okay.
It seems very clear so far. Thank you for this effort.
Good. So let's take a look at our implementation, which depends on this library. So there is additional data here to implement a whitelist. So effectively, we list here a number of addresses and we associate them with a flag that says whether it's this address is whitelisted, which is enabled to create a token or not. And here we have the token creators, which is relating any newly created token ID with its creator, which is also an address. And then there's another number of simple data, which is a flag that allows us to enable or disable the whole whitelist. So we can bypass the whitelist check if we turn this whitelist enabled to false, and a variety of preset parameters that determine the payout model that we are going to discuss soon. So this is all done to trace and enable the creator data to be located.
Mm-hmm. So when we're talking about creator, does that mean the artist it is here referred to as a creator?
That's right. This is precisely what it stands for. Alternatively, the artist could delegate a creator, and therefore the creator becomes someone else, or perhaps even the marketplace, or it's pretty flexible in this sense. But conceptually, yes, that's correct. That a creator can be identified with the artist. And as we see here, I illustrated with this part of the diagram, this one here, which has got two red lines. So effectively, these are functions that are that we can call externally. So we can create a token by providing a URI. This URI specifies where a work of art is located. For example, this might be IPFS. This is a popular location where you could store your artwork. And then when you post it into IPFS, then you obtain a URL which you can pass in here as an argument to this function. This function is called, it can be called externally. And again, this barrier signifies that if the creator has been enabled to the whitelist, then it can proceed, otherwise it's blocked at this level. Similarly, there are another set of functions that are used to control the marketplace. But before we dive into it, because it's slightly more complex, I would like you to take a look at the payout model, which is quite interesting. So essentially the payout model implements primary and secondary market.
Okay, that's very interesting.
Yeah, essentially there's a marketplace fee which is always applied. So the marketplace fee applies whether a work of art is sold in primary sale or in the secondary sale, and it's stable to 3%. For a primary sale means an artwork that is being sold for the first time on the marketplace, there's an additional 15% that is charged and goes to the marketplace. So in total, 18%. The creator receives for a secondary sale a royalty of 3%, and for the primary sale it doesn't get the royalty. This is because initially it will own the work of art, so therefore it will already receive an 82%
from the primary
from
sale.
the primary sale.
Gotcha.
So for the secondary sale, instead, the work of art will have passed to another owner, and this other owner will be able to charge 95% of the listed price, and the remaining 6% gets split between the creator, so it's a royalty that he will keep receiving for every trade that is made on this item, and also a 3% going to the marketplace.
Understood.
All clear so far?
Yeah.
That's good.
So you said 94. Okay.
94, yeah. Mm-hmm. So effectively, if you list it for one Ethereum, you get 94% of that Ethereum, and the 0.6% gets, sorry, the 6% gets split between the maintainer and the creator. Mm-hmm. Okay. So let's take a look at these functions that are used for trading.
So when we're talking about the maintainer, sorry, just to get this clear, we're talking about the marketplace.
That's correct. Mm-hmm. So the maintainer is also the owner in this case, which is a bit confusing, but it's a way this naming convention is chosen on our dependencies. So effectively, owner is the owner of the smart contract. Once the smart contract is deployed, this is referred as owner, this owner here. Okay?
Got it.
Which is not to be confused with a token owner, which is another thing. Okay, the token owner are registered in another data structure, which we have seen before, and we can get back to it.
Okay.
Allow me to get back to it so that we can clarify this part. Holder tokens and token owners are these two tables that relate a token ID with their owner and an owner with a token ID.
Okay. Yeah, I must admit the naming, it can be slightly confusing, but now that you explain it, it does make sense.
Right. So let's move ahead. Here there is also an interesting barrier, an entry barrier, that blocks operations in certain conditions. What are the conditions? Is that the artwork has to be placed on the marketplace in order for it to be tradable. So therefore all these functions are blocked unless the artwork has been placed on the marketplace.
So what does that mean, placed in the marketplace?
It means that they have been added to an approval sort of control, which is something that again we inherit from the dependency.
Okay.
And if the token ID has been enabled on a certain address, and this will be the address of the smart contract in this case, but it could be another operator that is delegated by the owner for that particular ID. In this case, instead it says that all the work of art, all the tokens that an owner possesses are approved for a subset of operators. Okay, and this is revocable. We can test both these approaches, but both are valid.
Okay.
So that means that either I put a single item on sale, or I put a whole range of items on sale. Okay?
Mm-hmm.
And before they get sold, you also have to specify a price, which is the first function that we see here among the trading functions. Okay, set sale price is invocable only by the owner,
Which in this case is the creator.
which for the primary sale is the creator, but for the secondary sale it might be someone else.
Okay.
Okay, and let's skip the functions that are related to the auction, so all the one related to bid. So let's worry only about these three functions. Set the sale price. So we specify the token ID for which we are specifying a price and an amount. And similarly, anyone else that is not the owner might come about and be interested in that price and purchase the token. In which case it says simply buy that token ID.
Mm-hmm.
And the amount specified when someone performs this call, there's a message value that gets set that has to match the price. We will see that when we dig into the code. Okay. Another function is for browsing, and it allows you to discover the price for a certain token.
What do you mean, discover?
It means that as you browse through token 1, token 2, token 3, you can check what is their price.
Mm-hmm. The price that's been set. Okay.
Exactly, which is recorded in this table here. It's called token price. So we have a token ID and its price connected. It's like a spreadsheet, these tables, effectively. So another data that gets recorded once the price gets set by an owner is a registration of who set the price. We will discover how this becomes useful in the code, but for now we can skip it. However, when a buyer comes along, it will be verified if it's got enough money to purchase at that price, and if so, the ownership of that token will pass to the buyer, who will become the new owner, and a flag will be set in the history saying that that token ID has been sold before. So this table is called sold before. And this is what determines whether the item is on the primary or secondary market. So once the token has been set to sold before, then it enters in the secondary market.
Okay, that's very clear. And it's good to know that this function does perform a check in terms of whether the person that is interested in making the purchase has enough funds to do so.
Yeah.
Okay.
So a quick look at the auction functions. So there's the possibility for anyone to place a bid, and this is possible whether the artwork has been placed on the market or not. So you can bid.
Of course.
You can bid, and it seems that with the current implementation, the owner can accept a bid, but before doing that, he has to set the work of art to be enabled into the marketplace. Mm-hmm. Otherwise, it cannot accept. This might be skipped in another implementation, but we are relatively happy with this implementation. It seems kind of reasonable. So once the owner is satisfied with the bid, then he says, okay, I'm interested, I want to get the money, and here's your token. Mm-hmm. Okay. In the meanwhile, a bidder can decide, no, actually I regret placing that much money on a token, then I cancel.
And they can do so? They
can do so, and they get a refund.
Is there a specific time set?
No, there's not a specific time. I think with this implementation, it's quite open-ended in terms of time. So obviously, this also depends on the implementation of the application that sits above this smart contract. So this is not defining the whole application. This is defining only the mechanics on the back end. So definitely there might be an implementation on top of it that has got a timeout. Okay. So, but anyway, there's the opportunity to cancel, in which case you get a refund. Be careful you don't get the full refund. You get the refund without the gas. Serena, do you know what the gas is?
I think I know, but if you don't mind to refresh it to me, it would be great.
All right. So here we are talking about some charges that get applied by the Ethereum virtual machine. So that is an approach that is used in order to collect money to incentivize miners to mine the next block on the blockchain. Right. So all this gas money gets collected by the miners, and also it serves another purpose. Is that because this type of languages that are used on top of Ethereum for driving smart contracts are Turing complete, which means loops are allowed, for instance. One of the approaches to avoid infinite loops is through this gas, because when you run out of gas, you automatically exit a loop, so you don't incur the danger of getting into infinite loops. So
can we say in a simplified way that this is a transaction fee?
It's a transaction fee, precisely. Yeah. Okay, so what you will get as a refund is the stake that you placed for the bid, and without the charge for the gas. Mm-hmm. Yeah. Here we have a function that anyone can call at any time for a token ID, and it will give us information about the bids that are active on that token.
Okay, and that is for us to find out the live bids on that specific token.
Bear in mind again that there might be an application on top of it that has got hold of all the data related to all the token IDs that were created, and periodically consults this in order to check their price and also who is the latest bidder. Okay, because in these tables we have a bid associated with a token ID, and also the address of the latest bidder. Okay, apart from the refund, which needs to check if you are, suppose you want to cancel a bid, it will need to check that you are the current bidder. Otherwise, someone else can cancel your bid, which is something that we would not want, right? But there's someone else that might go over your bid, in which case he becomes a new highest bidder, and the previous bidder gets refunded. That's the model.
Minus the gas transaction fee.
Yes, this is interesting because it slightly differs from traditional auctions in the sense that there's only one bidder at a time. And this is because the money, the amount that gets traded over this auction is locked away. So this is in order to prevent a situation in which the bidder doesn't have the money, or has the money when he places the bid and then he goes and spends it somewhere else, and then when it's the time for the owner to accept the bid, there's
no more fund. Okay,
yeah.
So it sort of freezes the amount set for that token ID.
Precisely, and it's also an approach that goes into the philosophy of performing trustless, independent transactions on the blockchain, so that you don't have to trust someone else that he will keep the money until it's needed. The money will be locked away and it will be secured by the smart contract in the underlying blockchain. Okay.
Got it.
Okay, I think
that's an interesting model.
Yeah, we spent about 20 minutes on this, and I think we are ready to go and take a look at the code. What do you think?
Let's do it.
Okay. I just went back on the previous page, and we can click here to see the gallery code. Okay, here we see that the gallery code is into this gallery sol file, and this is all in one place. So these are the data, the mappings that we saw in the diagram. We can skip through it, but there's a match with what we've seen before.
So what we're seeing here is the coding part of the diagram that you illustrated.
Precisely, and there's an initial part of this code that lists all the data.
Mm-hmm.
And then there's a part that invokes a constructor. It passes some data into the dependency. This is the ERC721 dependency of OpenZeppelin. We can see the dependency expressed explicitly at the top. OpenZeppelin contracts. This is the ERC721. And this is the ownable interface.
Okay.
Okay. So here we have a set of functions that is used to amend the fees. So the percentages that gets calculated for royalties, for the marketplace fee, and the primary sale fee. And then we have the function that sets the whitelist to enabled or not. And here's a function that adds addresses to the whitelist or removes addresses from the whitelist. And then a function that checks if someone is whitelisted.
Mm-hmm.
And then we have the interesting function that is create a token.
Mm-hmm.
So if someone has been enabled through a whitelist, it can create a token. And this again works on the dependency of the ERC721 library.
Mm-hmm.
And this function is the one that means create a new token, right? And then it sets the URI to the one specified in this parameter here. Okay, and then it also registered in a local table the token ID and links it to the creator.
Okay.
Okay, all clear so far? We are not going deep into all of this implementation, but essentially I just wanted to browse through quickly. I stopped on the create token because it's quite an interesting and central function. But then there's a set of modifiers. The modifiers are just pieces of logic that you can attach to a variety of functions. So you can define this piece of logic that signifies that the owner must have the marketplace approved, or the sender must be the token owner, and so forth. A series of checks. Even price setter still owns the token is a check. This is a function, is not a modifier. It's because of its particular use, but it's very similar to a modifier. Okay. Set sale price. These are all functions that involve the trade. Okay.
So what we're seeing here is an implementation done by SuperRare that communicates with the Zeppelin library.
OpenZeppelin.
OpenZeppelin.
That's correct. And the interesting part is that also you see emit. Emit is used to send out events that the application can subscribe to in order to trigger behavior. However, this has been commented out for this exercise because we are going to run it in browser. We will see in a minute, and therefore we are not particularly interested in emitting events. So we were more interested into defining the basic logic, and so we went through the logic for the trade in terms of selling and buying, and these are the functions that get the token price. We can skip through that. Then there is the payouts section that implements that model that we have seen in the diagram, right? So this is a set of functions triggered on the top level by payout. So payout has got an amount, which is the price of the token, and in the seller, right? And that means that a series of operations will be triggered in order to distribute the fees according to the calculations. Let's not go deep into that. I think it's gonna take too much time, but anyone is free to ask questions afterwards on the Twitter channel, so I can respond and perhaps even go on a one-on-one session with someone else, which we will be happy to record and publish. Okay, so and there's a final set of functions that is used for the auction, which involves bid, accept bid, and cancel a bid, and check the current details for the bid, and refunds, reset, and that's about it.
Okay.
So that's an overview of the code. Obviously, we didn't go into in-depth analysis, and bear in mind this is simplified code, and actually it's not production ready. So you don't take this code, you place it on Ethereum and run your own gallery. It's not been tested sufficiently, so it works for the purpose of this exercise. But if you intend to build your own system based on a smart contract like this, you better undergo a series of tests and validity checks, verification for double spending, re-entrancy, and a lot of bugs that might be there. Okay.
That sounds fair.
Right. So I went back once again. So now we are going to open the Remix IDE. An IDE is an integrated development environment, and is provided by the team of Ethereum, we are going to use Solidity as a language, so we can click in here, and then what we could do is import the code from GitHub, which actually we better get the link from before. So when we go again to browse for the gallery code, we can copy this URL. And then when we open the Remix IDE, okay, we can specify GitHub. We can enter that address that we copied. And here we will have our contract loaded in.
Super.
Okay, now we can compile it. So here it says compile the gallery.sol.
So what is it happening right now?
It's loading in all the dependencies from the OpenZeppelin library. And the compiling function is converting the code into a bytecode that gets executed by the Ethereum virtual machine.
But we're not performing actions on the actual chain now, are we?
No, actually that's a good point. Here we are running an in-browser simulator. So even if we spend Ethereum, these are fake Ethereum, so there's not a big deal.
You're not going to make me poor now.
No. But we haven't yet started even with the deployment.
Okay.
So we have just compiled, and this is a function that is totally independent from any sort of simulator also. So this is just a compiler. It's a verification that the code compiles, and in fact it comes up with a series of warnings as well. So some of the warnings are related to the dependency library. Some are excessively perhaps they are even unnecessary, excessively detailed. However, they stand, and someone can go and look into it and see if there's any potential weaknesses. There's a number of other verifications that can be applied on top of this, but we can get into it later because I think we need to get on with the deployment and trying to use the smart contract. So
I'm curious to test it now.
Okay, so in order to deploy it in a simulator, you go on here. So here you could also deploy it on an external blockchain. You can deploy it even on Ethereum. But what we will do, we'll deploy it on the JavaScript VM, which is an emulator, right? So again, we selected the contract here, the gallery.
Yeah.
And we triggered deploy. And we will see that this didn't work. Why it didn't work? Because it needed more gas than the gas limit that we specified. So it's possible to specify a gas limit in order to ensure that you don't spend that much. The gas is expressed in Wei, which is a very small number compared to the Ethereum. So an Ethereum is worth about $230 when we recorded this video. And however, there is the Wei is really a small percentage of that.
So we don't need to get scared by all these zeros.
No,
that's what you're saying.
It's a negligible amount.
Okay.
So I think in order to make this work, we have to double the limit, and we try to deploy it again. Bear in mind that you can choose from a number of preset accounts, each one of them having 100 Ether. So we chose this account to be the owner of the marketplace, let's say.
Right.
Well, 74 can be our creator, our artist, and this can be C1 could be the purchaser, the new owner.
Okay.
So C2 is the owner of the marketplace. So let's try and deploy it again. Okay, this time it worked, and as we can see down here, so we can also expand this, and we will see all of the functions that we have defined as external available here for us. So it's interesting because you can get, for example, the name, and the name is my gallery. We specified it in here when we call the constructor. We can check the symbol, which is MG, and we can check the owner, and the owner is C2. So let's go and choose another account. For example, say that the creator wants to check who is the owner of the marketplace that is going to use, and even here it will return the same, because
that verifies that.
Yeah, it verifies that it's the same owner. And interestingly, as you have noticed, because these are functions, the function listed in blue, they don't change the state of the smart contract. So they don't involve any write, but they involve only reading, and therefore they don't consume gas. So as we invoked from this account that owner check, it didn't consume any gas. So we still have 100 ether, while instead the first account consumed a bit of gas for the attempt to deploy that failed.
The one that failed but still consumed some gas, and then the second one that
and the second one that succeeded. Correct. Okay, so we are not going to try it, but if you try and create as creator, it will fail unless we whitelist this.
Oh, that's correct.
Yeah.
And how do we?
So first of all, the creator needs to be whitelisted by the owner of the contract. So that's what we are going to do now. So it's convenient to have here a button that allows you to copy this address. So now it says copied value to clipboard. Okay, that's copied. And we have to act as the owner of the marketplace to enable this creator into the whitelist. So we will specify it here. You need the double quotes. Here is the address and the square brackets, and we add it to the whitelist. Let's give it a shot. It succeeded. So now what we can do as the creator, or in fact I believe anyone else, I haven't tried, but let's try as the creator. The creator is interested to see if it's enabled.
If they've been whitelisted.
If they've been whitelisted. Again, the value is copied. We had it already in the clipboard, but I copied again just in case. And we can verify if that address is whitelisted. And it says true over here.
And can I ask you, Dom, how long in reality does this take, you know, these operation of whitelisting?
That's an interesting question. This is not specific for the whitelist. It's specific for any change of state that occurs. This depends on the performance of the underlying Ethereum network. So the Ethereum network operates at a certain speed and with a certain throughput. Throughput is how many transactions per second it can run through the perform through the network precisely. And as we know, the mining is a relatively slow process. This is bound to be accelerated when Ethereum 2 is going to be launched.
I heard.
Yeah, and there's other networks that have higher performance, but perhaps they have less of a redundant consensus, less of a wide peer-to-peer network to apply consensus. That's why, for example, Bitcoin network is still extremely attractive, because spread around hugely, and so therefore, in order to get control of the of a mining pool for the Bitcoin network, it costs really a lot of money. While instead for minor networks you could get malicious intervention by miners at a relatively low price.
What I wanted to understand here is that it doesn't depend on the SuperRare team how long the whitelist process.
Correct. Not only the whitelist process, but every operation. So if you, for example, set a price or create a token, these are all operations that depend on the performance of the underlying Ethereum network.
I see. Okay.
Yeah. So it's good that you raised it, because in fact sometimes people perceive that the company that they relate to, the gallery that they relate to, is not performing very fast. But in fact, it doesn't depend from them. It depends from the underlying Ethereum network. So in some circumstances, some of these operations take longer. We are talking about a range of possibilities going from minutes to hours. Yeah.
I see. Okay, that's interesting to know.
Yeah. So moving forward now,
so we now verify that
we are
whitelisted.
So the creator has been whitelisted. Again, it hasn't consumed any ether.
Because we're reading.
We have been reading, but now we are going to create, therefore we write. So in order to create, we have to specify the URI. The URI can really be anything. So for the moment, we can call it my artwork 1. Okay, and the creator creates a token. We pretend that this is a URL, which is not, but let's create the token. And it was successful. So now several variables changed inside here. So the first of one is the total supply, which is now 1 token. In fact, it returns 1. So let's go and create another one just to give it a shot. My artwork 2.
And I'm gonna ask you another question here. Every time that we create the token, can we do that in terms of bundles, or do we have to perform this operation as a one by one?
That's a good question, but again, this might depend on an application built on top of this backend. So the application might push in one by one, but you don't see it.
Okay.
Okay. So let's create a second one. Before we create the second one, we also observed that we consumed some gas to create the first one. Again, a negligible amount. Okay. But let's create another one and check the total supply for the smart contract. This is a variable that belongs to the whole smart contract and tells you how many tokens have been created. Oops. And it says 3. That was unexpected. Did I press the button twice? Possibly. Okay. That's interesting. Let's go and check the token URI for which one of them. It's a way to find out what happens. So the token URI for token 1 is my artwork 1. The token URI for artwork 2 is my artwork. For token 2 is my artwork 2. For the third, given that we had a third one coming about, is again my artwork 2. So I made a mistake. I pressed the button twice. I created 2 tokens with the artwork 2.
And okay. Is that something that you can do?
Yes, you can. There's no check against it. Okay. So anyway, let's proceed by trying to set a price and try to put on sale one of these tokens, because we created and we want to get some money. So we will set a price. Set sale price. Okay, set sale price is a function that I've created on top of a set way sale price. If you go and look at the original code in SuperRare, there's only set sale price that operates in way. But because here I wanted to distinguish prices in Ethereum for our convenience, so that we can observe changes better in this exercise, I created this set sale price function. So the set sale price needs the token ID. So in this case we are trying to set for sale one of the two duplicates, the my artwork 2 that accidentally I created twice. So let's put it on sale for the token 3 at the price of 1 Ether. Set sale price, and it fails. The reason is the owner must have approved marketplace. Okay, fair enough. So first I have to put it on the marketplace. So let's say the token 3 is approved for the marketplace. The marketplace is the gallery. So let's just copy this address from here. And let's get it approved. And I think I made a mistake. Yeah, I got the order wrong. First goes the address and then the token. I placed it the other way around. So first the address of the marketplace, followed by the token number, which is 3, that we want to approve. We could approve them all with a set approval for all, this function here.
Right.
But for the moment I'm just happy to place that specific item on the marketplace. So let's place it to approve, and this time it's gone through. Okay, that's all good. And now we can finally set the price to 1 Ethereum. So before we do that, again, let's go and check the price for the token price 3, and it's still 0.
But we haven't set
it yet. Now we are going to set it. So set sale price, and now we will see that it's going for 1 Ethereum. Okay, again, this is the converted Ethereum in way. This is how many ways it will get you to purchase. Okay, so let's observe what happened in the account. We consumed a bit of gas for our operations. This guy, the gallery, the marketplace owner, also consumed some gas. The token is for sale. This is the buyer, C1, who comes about and wants to verify the price for token 3. And again, he finds out that this is 1 Ethereum. So he says, okay, I'm interested and I want to buy it. Let's keep an eye on these other parameters here. So here are 99 and 99. So what we expect is that when we sell for 1 Ethereum, 82% of the Ethereum will go to the creator. And 18% goes to the marketplace. Because Correct. It's a primary sale. Okay, so let's see if that's the case. So we are going to purchase for 1. Well, we have to change the unit to Ethereum. Okay, and then finally we can go and say buy token 3. It has succeeded.
Hooray!
So now we spent 1 Ethereum. So it went down.
It went down by 1.
Down by 1 plus a bit of gas. Well, instead these two accounts went over. So 82 and 18.
Right.
roughly speaking. Again, some gas goes away that gets always spent against the Ethereum network.
So even when you receive a percentage, do you?
No. It was spent before.
Before, of course.
Yeah, no,
okay.
When you receive, you don't pay Ethereum. Sorry, you don't pay gas. The gas is paid by who executes the function.
Right.
Okay, so but we have seen the split. So let's try to see it again by having this 20 address that comes about in, let's say that this time we place a bid.
Okay.
Okay, we
Let's try
place a
that.
bid for 2 Ethereum, right? Let's give it a shot. The account 20 comes about and sees that the artwork number 3 has been sold, and so it says, okay, this is a promising
I want to put my
asset.
bid.
Yeah, so I want to come about and buy it for 2 Ethereum.
So we are now placing a bid.
We are now placing a bid on token 3.
Okay.
Okay. The bid has gone through. So let's see what happened. We went down by 2. This is 98. Let's always think in those terms, approximate. So nothing else has happened. Okay. But let's check what is the price of that token. The price is 0 because it's not on sale.
Right, so that's another question I had for you.
Yeah.
Once I made a purchase, let's say I purchased artwork token number 3, do I need to approve and decide whether these is still available on the marketplace, or can I just remove it and own it and I'm happy with that?
I'm not sure I quite understood the trade.
So once I made a purchase,
yes,
right, and somebody else wants to place a bid,
yeah,
okay, do I need to decide whether I would be happy to accept bids, or can I just say, no, I'm happy with my purchase and I just simply just remove it from the marketplace?
with the current implementation, there's not the option to remove it from the marketplace. By definition, they are removed from the marketplace, but you can still place bids against it.
And then it's up to you whether you want to accept it or not.
Absolutely, yeah.
Okay.
But bear in mind, as we said when I showed you the diagram, is that first you have to set it to be approved in the marketplace before you accept the bid.
Got it. Okay.
So you can skip all that by setting everything to the enable marketplace by using the set approval for all functionality, which we might see executing later. But for now, we haven't tried it.
Okay.
So that allows for one owner to get all of his work of art always tradable. Okay.
I see. So that is something that you can decide.
Yeah. With this particular implementation, there's no check on the bid. So anyone can place bids at any time.
And also remove them if they wish to.
Also remove the bids if they wish to, and also go over someone else's bid. In fact, we might give it a shot.
Okay, let's try.
So, but first, let's verify that the bid has gone through. So we placed the bid for token number 3, and so let's check current bid details for token 3. So there's a bid for 2 Ethereums by address number 20. Let's see if it's the one that we chose. Yes. So let's then pretend that someone else comes about, B1, and says, this guy placed a bid for 2. Let's place a bid for 3. Okay, take a look. The account number 20, which is the current highest bidder, is down by 2 Ethereum. So when we place our bid and we go over its bid, then this account will bump back to close to 100 minus some gas, obviously.
Okay.
Okay.
So it will automatically return the bid that was placed minus the gas.
Yeah. Let's go much higher. Let's go to 10. Okay. just because so we can see the simple calculations going through when we later are going to accept this bid.
Okay.
So let's proceed, and we place a bid on token number 3 once again by being this B1. Okay, and it goes through. So let's go and check the accounts now. So the previous bidder has received back his money, and this one is gone down by 10. Okay, so the money is locked away. No one has yet earned it, so it's stored in the memory of the smart contract with this
kind of freeze somewhere.
Precisely, with this address associated to it, B1. Okay, so now that the current owner, who is this one, so this ceases to be the current owner. This is not the current owner any longer. This was the creator.
Because it was sold.
It was sold.
Okay.
So this is the current owner. Let's just verify it if it's true. We say that the owner has to be C14. Owner of token 3 is C14, indeed. So this guy might go and check the bid details, and he says, wow, 10 ether, I want to accept this bid. So he goes here and says accept bid number 3, and he forgot to have the marketplace approved for that token, so he approves the marketplace for that token. We have got already the data inside here.
So who does perform these operations when you say
the owner?
The owner, okay.
So the owner of the token. So now we set it to approved. So now we can accept the bid number 3. Let's give it a shot. Yeah. So let's see the accounts above. So the owner got its fair amount of tokens. So it was 97 if I recall correctly. So it should have got 94, if I remember correctly, 94%.
So 3% will go back to the...
3% will be distributed because this is a secondary sale. It will be distributed between the creator and the marketplace. I didn't check properly before we did this operation.
But it seems like it worked because it bumped up.
Yeah, if we want to write down this number and verify it, we are happy to do it. But I think time is nearly up.
So this gives us a good illustrations of how the royalty system work in terms of secondary sales. So we've seen a primary sale and how the creator and the platform, the marketplace, get their reward. And now we've seen how over a secondary sale, once we accept a bid, after placing a number of bids, we need to approve it, and then the creator will get, what was that percentage of royalties that they get?
It was 3%.
3%. And how much?
For the secondary sale. For the primary sale is 0 because it gets the whole...
The creator, of course. Yeah. And how much does the marketplace still get on the
3%.
Okay, so it's a split of...
The marketplace gets a fixed 3%, and for the primary sale it gets an additional 15% with these parameters that were set. But you can amend these parameters. You can decide whatever you want.
Right, but we can rest assured that the artist will always get a 3% on every secondary sale.
That's the purpose of this design.
So that's a good way for the artist to keep getting rewarded for their wonderful work.
Yeah, that's correct. That's the idea. That's the idea to apply royalty for every time that this work of art gets traded on this market, which is interesting. As we know, it doesn't always happen in the market for physical items, but this is an interesting approach. And further enhanced model will be studied both by SuperRare, but we are also involved in studying additional models that define copyright and trade possibilities. Yes, stay tuned for more, because we are going to publish what we will discover and in a subsequent range of workshops.
Great.
Yeah.
Thank you.
I hope you enjoyed it so far. Feel free to connect over Twitter in the MoCDALab that we have established, and we will be happy to respond. Obviously, this doesn't go straight away, but it's reasonable to expect an answer in a matter of a day or so.
Okay.
And yeah, and if you have a very interesting advancement to propose, we can also jump on a call and have a one-on-one session, so that we can record it and make it available on our social media.
Okay. Well, Dom, I have to say thank you so much for doing this amazing work. It really made me understand what's happening behind the scenes of a smart contract. And I just want to spend a couple of words to say thank you to SuperRare for making these available to us and get us the possibility to study what's happening in the gallery. Thank you to the artists and everyone who uses the platform, and thank you to Kara for allowing us to present this as a preview of our series of workshops at MoCDALab. Thank you to all the sponsors and people that have been supporting this work. We're here to help, so please feel free to get in touch through social media, Twitter. We have a newsletter, and also on Instagram. We're here to help and to learn together. So thanks once again, and we shall see you very soon.
Okay, going back to the page, if you want to join the tweet, you just click on this link, and here are the contributors to this effort.
Thank you to NFT London Meetup, Everknow, which is run by Dom, SuperRare, and MoCDA for putting these together. And thank you, Kara, for allowing us to present this workshop for the first time. This will be recorded, so feel free to watch it at your own time. And if you do have any question, once again, feel free to reach out through Twitter or our social media and website. Thank you once again.
Okay, bye-bye. Thank you.